So let's commence for today. So today we have a special guest. So today's lecture is going to be given by Prabuchandran. So Dr. Prabuchandran. So he is an assistant prof in IIT Dharwad. So he works in the area of reinforcement learning. He also offers that course in IIT Dharwad. He also teaches things like statistical learning theory, and yeah, so his area has always been in and around probability, and he has new insights. I mean, he has different insights from me, and I guess it's good to always have a change. So for today's lecture, I have invited Prabhu Chandran, and I'm happy that he has accepted it. So I think with this introduction, I will let him continue. So
okay. Yeah, thank you, Satya. So I'll just turn on the video and say hi to everyone. I hope everybody can hear me, right? Okay. So there are two things. What I would say is you can use the chat window and then ask some questions, or a better thing would be to unmute your mic and then just ask the question. So I would like this session to be interactive. Okay. So let me present my screen. Please see if you can see my screen, and we will start. Okay. So maybe chat window, there may be a difficulty because I'm going to present through the screen. So I would suggest you guys to just unmute and ask questions. We'll go very slowly. Okay. So today what we'll be doing is to look at what is probability and why is it useful to us. Okay. So maybe I think what I'll do is I'll try to, the video I will turn it off. Okay. So the reason being bandwidth, I'll try to, it will be better. Okay. So I hope everybody can see my screen. Satya, is it visible?
yeah, it is properly visible for me.
Okay, all right then. So, sure. Okay, if everybody is fine, let me move on. So I will ask you a couple of questions before we start. Okay, so can you guys tell me what is an application of calculus? You guys have been studying calculus in your maybe 11 plus 1 plus 2. Now, have you guys seen any utility of the calculus, or where does it get applied? Do you guys have any idea? Anyone?
To calculate the gradient descent, we were using a gradient, so it was
very good, fantastic. Yes, good. Okay. Anyone else?
To calculate the area under a curve.
Okay, very good. Yes. And area under the curve, have you used it somewhere? Have you used area under the curve in any place? Why is it required, such kind of thing? Fine, you think about it, no problem. See, definitely area under the curve is a useful thing to compute. Maybe you need to compute for different designs how much paint you have to use and etc. So it is definitely required. So the area under the curve. Anything else?
so we can use the
computer architecture, is it? Architecture? No. Which one you are using it for what? Sorry, there are two voices. One can answer.
Yes, sir. We use it to determine some material properties like modulus of elasticity and all for the materials, wherein it is
Correct.
basically the slope of that curve.
Correct. Very good. Okay, definitely. Okay, so slope is an important concept.
Yeah, and
so
then another property is like toughness and all, wherein we use the area under the curve concept to determine the toughness of that material.
Okay, so you are from which discipline?
I'm from mechanical discipline, sir.
Very good. So yeah, mechanical guys will be able to definitely appreciate, but computer science guys will have to. There are multiple uses. Definitely, you guys have spotted some of them. It can be used for even counting and some approximations, etc. So you'll be studying about generating functions. So calculus is very useful. Now let's look at probability. Where do you think it is useful? Where is it getting applied? Or have you seen its utility yourself? See, calculus, you have seen it in very close quarters. Have you seen similarly for probability in a similar way? Anyone? Where have you seen the probability getting used?
So
Or
machine
what is
learning.
probability? Yeah, tell me.
So machine learning is heavily used
Okay,
probability.
correct. But have you seen where exactly in machine learning is it getting used? It uses probability, I agree, totally agree. Yeah.
So whenever we have given a data set, we always plot a histogram to see the pattern.
Okay, maybe their probability is getting used. Fine, good. But so what I would want to do in this session is to show you some applications of probability. Okay, and where you can see that it is really getting used, and it will get used in other applications as well. So more, I would like to hear more answers if anybody has any other suggestions.
So we can use probability for classification problems in machine learning, like in logistic regression.
Mm-hmm. So why is it? Where is it getting used in logistic regression? What is it?
So basically, we select a group, a class, and we assign probability to it, and we check and we compare it with other groups. And whenever we take test data or
No, you have to
data,
tell me where is this probability getting used. Like that is what you have to try to relate to. Definitely, I understand it is getting used in somewhere or the other. Where exactly you have to spot me the place.
Sir, can I try?
Yes, definitely.
So, we can say that softmax function will be using the probability.
Yes, correct. Okay, good. Yeah, very true. So definitely it is going to get used heavily in machine learning. Yes, you are right. Softmax function is, so basically in machine learning, these are all probability models. And if you want to understand probability models, you need to understand probability basically, right? Okay. Now, typically probability has been used and it helps in decision making. So what I would like to do in this talk is to convince you that at least we'll see. So probability helps in making decisions when there is uncertainty with us. So essentially probability is a study of systematic study of how to handle uncertainty. Okay, what do you do, how to take decisions when there is an uncertainty around. That is what probability is about. And another application I will give in terms of using probability to perform integration. Okay, and final application will see how some determinism can also come out of probability. Okay, so these are the three things around which I will be talking. Fine, so let's start. How many people have heard about Monty Hall problem? Anyone? No one?
Yes,
Not
sir.
even one?
Yes, sir.
Yes, sir. We have got it.
Yes, sir.
Okay. Okay. All of you guys, so how many some people do not know this problem, right? As well? Some of you, is there someone who have not seen this problem? At least, that also is important, that's why. Anyone? Or everybody in the class knows about this problem? Okay, I don't know what does that mean. So I would assume that everybody knows this problem then? Okay, all right. Then whoever knows this problem, how many of you have understood that whatever solution it has is correct or not correct? So some of you guys said yes, right? Guys? Some of you guys said yes, you need to answer me. If you guys know how this problem works.
Sir, if we know that if we know that
sorry?
Sir, if we know in the case that it's the door number 1 does not has that won the lottery.
Oh, okay. So then let me state the problem. What my question? See, what I'm going to do is, my question is, see, you said you know the solution, but do you guys understand it completely? Is it convincing for you? Is my question. Whatever solution you have seen, is it convincing? Okay. Sure. Anyway, so let me define the problem for the benefit of people who have not seen this problem. Okay. So if anybody has any question with the problem statement, please let me know. Okay. It's good that you guys are aware of this problem. So what we have is 3 doors. Okay. Behind 2 of the doors are goats, and behind one of the door is a treasure or a car, whichever you guys want to imagine, you can imagine. So now you have 3 doors. So I would want someone to volunteer. Okay. So one of you can choose one of the doors. Anyone? Someone we can take. Anybody? Someone was speaking with me, right? You can volunteer and choose some door number. Which is your door number? What would you choose?
Door number 1.
Okay, good. So that is your lucky number. You chose 1. Okay. Now, as a host, I am the host of this show. I'm going to ask you, okay, this. First, what I will do is I am going to open one another door which contains goat. That I can definitely do because there are 2 doors which contain goats. Okay. Then, after I open this, I'm going to ask you this question. Would you like to switch your decision, or are you going to stick to the same decision?
Sir, I would like to switch.
Okay, good. So you would like to switch. Anybody who wants to stick, you tell me. Stick to the decision what you have. So is the problem clear to everybody at least? If anyone is not clear about the problem, I'll repeat it again.
So Prabhu, just I want to add a few statements. So here, so basically this is a random experiment. So what is the randomness here? We don't know where the car is. Okay. So that's the random. It could be behind 1, it could be behind 2, or it could be behind 3. So omega is basically the sample space consists of all possible places where the car will be there. So it could be 1, or it could be 2, or it could be 3. Okay. And the probability that it's on 1 is equal to that probability that it's behind 2 is equal to the probability it is behind 3, and that's equal to 1/3. Okay. So that much is fine. The next thing is like, okay, so Prabhu just did it. So he asked Siddhant to choose a door. Siddhant chose 1. Okay. Now, irrespective of whether there was actually a car behind 1 or not, there is a way for Prabhu to always show a goat to Siddhant. Okay. And then the question, what the host asks is, do you want to switch? And that's like, I just wanted to summarize this problem.
Sure.
Yeah, that's about it.
Yeah, that's good, Satya. Yeah. See, if anybody has any question, please ask, okay? Because it's important that you participate, and then only you will understand the benefit. If you do not participate, if you miss the details, then you will not even understand the solution. Okay. So I think I'm speaking to Siddhant. Okay, Siddhant. Okay, so you said you would want to switch, right? Why would you want to switch?
Sir, in the first case, there was the probability of me choosing a wrong door was 2/3. And then you showed me a door which was not having the car. Right. So the probability that I chose the wrong door was already a lot more. Like it was more than 50%. That I had chosen a wrong door.
Okay.
So if I want to win a car, I will definitely it's not sure that I will definitely win a car, but to increase my chances, I'll change my answer so that there's more probability of me winning the car.
Yeah. Correct. Fine. That is your justification. We'll see more details. So anyone else would like to volunteer and you want to stick to the decision and they don't want to change their decision? There would be some people, right? Anybody is volunteering for that?
Yes, sir.
Very good. Yeah. What is your name, by the way?
Satushar.
Okay, Satushar. Yeah. What is that you will choose first? Let's play the game again. Since it's a random experiment, I will replace everything back. So we won't know the outcome of whether Siddhant won or not. So let's go to you, Shushar. So what would you choose? 1, 2, 3?
Sir, door number 2.
Okay, door number 2. Okay, now suppose I am going to open door number 3. Okay, and show that there is a goat now. Okay, now would you want to stick to your 2 decision or would you want to switch to 1?
Sir, I would like to stick to my decision.
Okay, good. Thank you. So why would you want to stick to your decision?
Sir, all of the 3 doors having same probability of having the car is 1/3. But the doors having goat, that probability is 2/3. So now I am left with 2 doors with equal probability. Now, yet I have equal probability. So maybe it is in door 1 or door 2.
But then you could have switched even, right? 1, you could switch, right?
Yes, sir.
You could switch also. There is nothing wrong. But I could have tricked you somewhere, right? Possibly.
Yes, sir.
So that's why you don't want to change your decision, right?
Yes, sir.
Okay, good. See, there are two reasonings given. One given by Siddhant, another by Sushar. Okay. The reason why we need to understand this problem is, if you don't understand the problem completely, you may end up in the wrong decision. We'll see. One of the reasoning will be definitely wrong. This problem has been given to many PhDs from math, and even they have got confused with the reasoning. Okay, you have to be extremely clear in the concept, then only it will be easy for you to follow the solution. Okay, all right. So let's look at it. So the reasoning what Sushar gave is, there are two doors, and anyway, out of the two, 50-50 chance is there to pick one of them, treasure being present behind one of them. So it's better to stick to the same place wherever I have chosen already. All right. Now, let's see. I will re-ask this question again to Sushant. Let's see what he has to tell. Sushant, are you there?
So it's
Yes, sir.
Tushar, Prabhu.
Yeah.
Tushar.
Hello? Yeah.
Yes, sir.
Oh, Tushar, is it?
Yes, sir.
Okay. Satya, what is his name?
Tushar with a T.
Okay, Sushant. Tushar.
Uh-uh.
Tushar. Okay, all right. So, Tushar, you have 1,000 doors. Okay, same problem. I'm going to change it slightly. I have 1,000 doors. Which door would you like to pick?
Sir, door number 1.
Okay, thank you for picking the same thing. Okay, now I'm going to open 9998 of them. So 998 of them, and one door will remain unopened now, right? So I'm going to open all those doors which contain only goats. If I open the door which contain treasure, there is nothing treasure you are going to get. So what I'm going to do is, I'm going to open 998 of the doors which contain goats, and I'm going to leave you with another door now. Okay. Now what would you want to do? There are two doors now. Would you want to switch, and or you want to stick to your decision?
Sir, I would like to stick to my decision again.
Even now? Okay. Why? This is a 50-50 chance is there for either door to have.
Yes, sir. Yes, again 50-50 chance is there. But before that, I had very low chance, like 1 upon 1,000.
Okay.
So maybe I will now switch. Yes, I will switch to the other door.
Yeah, now you see the point, right? See, let's try to understand this problem in this context. See, initially you had 1,000 doors, okay, or even million doors you can imagine. Now, the chance that you are going to pick the door which contains the goat is seemingly impossible, like very unlikely, 1 in 1,000, okay, very unlikely. Then, but I'm opening 998 of the doors which contain goats. So, which is making sure that you are not going to pick those doors which contain goats. How likely is it to pick the first door behind the treasure versus first door behind a goat? So that is the question we need to understand. So Tushar, what do you think? The first door, what is the probability that you will pick a door which contains a goat versus a door which contains treasure?
So the probability is 1 upon 1,000 to pick a door which contains the treasure, and it is 999 upon 1,000 for goat.
Correct.
So
yeah, it is very, very likely that you are going to pick a goat first time. Okay. And when you open the door which contains the goats, the rest of the doors which contain the goats, then your chance of picking the first time the goat is going to translate to your winning probability. So that is what is going to happen. So the point is this. This is just an intuition, and we will see how to formally do the same thing using some omega, etc. But I hope the intuition is clear that the unlikely chance of treasure will make you lose if you don't switch. Okay. So let's try to understand this. And then, so what is the possible outcomes of this experiment? So it is important we define that. Okay. Thank you, Tushar. So let's try to understand in that form. So what I want to say is there are two components to the outcome. The first component denotes what we choose. For example, Tushar chose door number 1. It may have a treasure or it may have a goat. So I'm going to name this goat G1 and G2, white or black, whichever is convenient to you guys. Okay, so the first component can be either T or G1 or G2. These are the three possibilities. Let's go back to the original problem. I'm talking in terms of the original problem. Okay, now what is the second component denote? So finally, the second component denote what you finally get it. So for example, if we choose G1, okay, then definitely I need to choose, I need to show a door which contains goat. Then T is the possibility. So G1, I think G1, okay, so I think what is the second component? Sorry. So the second component here denotes what the host has shown you. So the first component denotes the choice G1, G2 or T, which you have chosen. The second component denotes what the host has shown you. The host can show either G1 or G2. So that is what is in the second component. Is that clear to everybody? Okay.
So
now,
one thing, Prabhu, just let me even add. So
sure.
when I described this problem, I told like where the omega, I told behind which door the goat is. Okay, that's one way of doing it. But this way, if you do it, the analysis becomes easier. So the first, so there is it's a tuple, right? There are two elements in each omega. The first one is what the contestant chose. Okay, and the second position is what the game show host is showing. So
yes.
So contestant, there are two goats. Imagine the goats have been labeled G1 and G2. Okay, maybe there are two goats by name Prabhu and Satya. So that those are the two goats.
Okay.
So Prabhu is first, Satya is second. So the contestant chose the goat Prabhu. That's one way. Or the contestant can choose the goat Satya. So these are the two ways it can happen. And when that happens, the game show host is obligated to show another goat. That's how the game proceeds, right? So it will show the goat that has not been chosen. So this happens in the first two omegas. Then in the third omega, what is happening is the contestant is actually able to correctly, somehow by chance, choose a treasure, right? Now, the game show host has two choices. Either he can choose show the goat 1 or show the goat 2. So this is another way of writing the same omega. It is more suitable for analysis. That is why he has written it this way. Okay.
So it is problem. It is just a person dependent, and it is based on convenience. You can choose suitable omega. So for this problem, both may work, but as he said, for analysis, this is very convenient. So let me ask this question: what is the probability of G1, G2 this outcome to come? What is the probability of this outcome? Can anybody answer other than Siddhant and Tushar? Anyone else?
Sir,
So let me ask, what is the probability the G1 is chosen in the first time? What is that probability?
1/4.
G1 chosen in the first time. I'm just asking that. Why is that? 1/4?
G1.
My question is, what is the probability the first component is G1? That is my question.
So 1/2.
1/3, right? Is that
1/3.
Yes. Okay. So now what is the probability G1, G2 is the outcome then? What is your name, by the way?
Mahendra Kumar.
Okay, Mahendra Kumar. Yeah, tell me. What is the probability of G1, G2?
1/6. As per the table space, it is 1/4.
Why is it 1/4? Can you explain?
1/6.
1/6. Who is saying 1/6?
Rohit, sir.
Why is it 1/6, Rohit?
First we have three options: G1, G2, and the T.
Treasure.
So that's why we got 1/3, and the second time we have G2 and T. So that's why we got 1/2. So G1 and G2 is multiple.
You have to see, is there any second component which has T, Rohit? You said G2 and T, right? But the second component, there is no T, right? Why is that?
Because that will kill the problem.
Yes, no, that's why what you have to see the question carefully. Second component denotes what the host has shown you. Host will never show you treasure. Okay.
All right.
So host is going to show only G2. If G1 is chosen, definitely he has to open the G2 door and then show it to you. So treasure is the one which is there in the other side. So G1, G2, for what is the probability? Can you tell now again?
Sir, it's just 1/3.
1/3.
1/3. Very good. Who is the other person? Someone else
Advait.
also. Yeah. Okay.
Advait and Sanjay.
Okay. Thank you, Advait. Okay. So G1, G2, I hope everybody is saying that it is 1/3. And what about G2, G1, Advait?
1/3 again.
Okay. Very good. So someone else, can they tell what is the probability of TG1?
1/6.
1/6.
Very good, very good. So same as for TG2, right? Okay. Now let me just write down what you guys said. There is no confusion. Everybody is in the same page now. G1, G2 is
Prabhu,
1/3. Anybody is not clear? Please ask me now. We can reiterate again.
Prabhu, just one more thing I will just say.
Sure, sure.
So I think G1, G2, G2, G1, both the 1/3 is clear. Just TG1 and TG2, I would like to explain little bit. Okay.
Okay.
So the probability that the contestant chooses the treasure is 1/3. That everybody understands. But now the game show host has to decide among which of the two goats to show, right? So that is why he's going to choose one of them equally likely. So that's why it is like 1/6, 1/6. 1/3 probability divides into 2, becomes 1/6, 1/6.
Correct. Very good. Yeah, that's good, Satya. Thanks.
Yeah.
Yeah. So now the question is, which are the outcomes favorable if we switch? Let's try to understand that. I should have asked you, but anyway, that's over there. Why is that true? Can someone explain which outcomes of the 4 outcomes will be winning outcomes for you if we switch, if we take the decision to switch?
Sir, if we choose the wrong door, like the door with the goat, and then we are shown a door which was another door having a goat. So if we switch, then we'll definitely go to treasure.
Very good. So this G1, G2 and G2, G1 definitely is going to give you a positive winning outcome. So let's look why TG1 will not work. So if suppose you chose the one with treasure, I could possibly pick one of the goats, G1 or G2. Then if you switch, then you're going to lose. So that's why TG1 and TG2 are not your favorable outcome. So this is the outcome which is favorable to you. Then what is the probability that W happens? That everybody knows, because these two are disjoint events and it is just 2/3. So the probability of winning is 2/3, right? Okay. Similarly, if you don't switch, what are all the outcomes favorable for you if you do not switch? So if you want to stick to your decision, then you should have chosen the door which contains treasure in the first place, which is TG1 or TG2. In either case, even if the host shows you whichever goat it contains, if you are going to stick to it, then you are not going to lose in that case. So these are the 2 possible outcomes. So what is the probability of this? 1/6 plus 1/6, which is 1/3. All right. Is there any question here so far? If it is clear, we can move ahead. If there is any question, I can take it. Okay. Fine. All right. So what is the conclusion? If you try to switch, there is a 2/3 probability of winning, which is like 66%. And if you don't switch, 33% probability is there for you to win. Okay. If you do not switch. So obvious thing is to choose the decision which has higher probability, which is switch. That's why I think Siddhant chose the the switching option. But Tushar, even though felt intuitively whatever decision he's saying is correct, without full analysis, it may lead to wrong decision. That is why you have to be careful. But Tushar changed this explanation once we saw if we have 1,000 doors. In an exaggerated situation, what happens? Once you see that scenario, then Tushar was able to easily understand it's very unlikely to choose a door which contains a treasure and don't switch then onwards. So better to switch. So that is what he changed later. So this is the simulation outcome of the same experiment. So this is many people have played, like 1,000 people have played this game. And in that, if you see, 66% of the population were able to win by switching, and 33% of the people have won by not switching. So it's clear now to everyone that switching is a winning strategy. Okay, so that is the conclusion of this particular problem. Yes, Satya.
So if you show this graph there, just go back.
Yes, yes.
So this graph is obtained from simulations. So what that means is, see, I have shown you one example in the class on a Python notebook where we did simulation to estimate conditional probabilities. So likewise, you can even do this entire operation like whatever he described as a simulation, and then check which of these 2 strategies is better. Okay, so I will ask you to generate this graph as part of assignment soon. Okay, so yeah, yes, Prabhu, that's all.
Okay, so one second. Let's continue now. So we have seen one simple instance of decision making problem. Okay, under uncertainty, there was an uncertain situation, we need to take a decision, and we have seen switching helps in this scenario. Now let's go to the other scenario, okay, and see what you guys will do. Okay. So the choice 1 will be this. I'm going to give you 1 rupee for sure. Okay. And the choice 2 will be, I'm going to give you 100 rupee with probability 0.9. Okay. Otherwise, you have to pay me 10 rupees. So that is with 0.1 probability, you have to give me 10 rupees. So let's X denote the amount you will get. Okay. It could be negative as well. Okay. As you can see, because 10 rupees you need to pay me, right? So what you guys will do here? Would you prefer choice 1 or choice 2? Anyone want to volunteer and then tell me which of the choices they are going to be choosing? Guys, choice 1 or choice 2? Okay, good. Your name?
Choice 2, sir.
Choice 2. What is your name, by the way?
Advait.
Yeah, some names. Advait. Okay. What other one? Who said choice 2?
Sir, Siddhant.
Okay, so 2 choice. Okay, Siddhant has told choice 2. Advait has told choice 2. Why would you choose choice 2, Siddhant?
Sir, it's like if I go for choice 2, there's a high chance that I win 100 rupees, and a low chance that I have to pay 10 rupees. Even if I pay 10 rupees, that won't be much of a loss. So let's go for like, this is not mathematics. This is just like what I would really prefer.
So if I change the probability 0.9 to 0.6, would you still go with the same option?
No, not that much, sir. Like at 0.9, it's like there's much more, like I'm much more assured.
But if I change the number 100, instead of that, if I make it 50 or something for the same 0.9, will you change your decision?
Yes, sir.
What will you do? You will go for choice 1 then? If I give 50 rupees with 0.9 and 10 rupees you need to pay for 0.1, what would you do? You will go to choice 1,
No.
is it?
No, then also choice 2. But if you decrease it to like
what level?
Plus 10 and minus 10, then I'll go for then I can
plus 12.
Sir, it's just about the amount of money you're offering me. If you offer me,
so how are you deciding? See, you are deciding. I know. Finally, you have to tell choice 1 or choice 2. But there is an underlying logic which you are using to decide, right? So, do you have a logic? That is my question.
Yes, sir.
Yeah.
For
Advait,
the second choice, yes, sir.
Oh, okay.
The
Advait, go ahead. Yeah.
probability of us winning is 0.9 and the gain is 100 rupees. And the probability of loss is 0.1 and we have to pay 10 rupees. So if we like calculate 100 into 0.9 minus 10 into 0.1,
okay,
then we have a expected gain of say 89 rupees. So as long as that remains positive, till that I will choose choice 2.
Okay, so as you can see, Advait, he did some kind of calculation, but Siddhant, he was coming up with intuition, but the main thing is you have to understand the logic. So we'll try to understand the logic what Advait has suggested. Okay, so he computed something. What is that quantity? Why did you compute that quantity, Advait?
Sir, it is like
what is that 100 into 0.9?
Expected amount that I will have to give or I will get.
See, if you play this game, so what Advait has suggested is this. If you play this game multiple times, how much you are going to get? That is what is the quantity he computed. That is what expectation he was saying of something. So if you play this game many times, let's say 1,000 times, of that there is 90% chance that you are going to get 100. So 0.9 into 100. So you can do the calculation and you will compute some number. So that for one iteration, how much is what he computed. And based on that, he decided whether it was choice 1 or choice 2. Okay, so let's go ahead and see how to do it. So Advait, he suggested expectation of X. Okay, but it is also another quantity is also important, which is known as variance. Do you know it of Advait? Variance, what is variance?
The change from the expected value means like plus or minus between, in that range I will.
Okay, good. Yes. So correct. Let's first compute this thing and then see what it is. See, variation captures variance of a X, which is a random variable here, which you are going to learn in that course, is going to be how much variations you are going to see. Okay, we'll understand that quantity later, but let's assume what is for the choice 1, what is the expectation? It is 1. No change is there. So variance is also 0. I think that is clear to everybody. Okay. So let me go to the choice 2. In the second choice, Advait computed 100 times 0.9. Okay, 90% of the time I will get 100, and I'm going to lose 10 rupees 10% of the time. On an average, I'm going to gain 89 rupees. So this 89 denotes if you play multiple games, then on an average you are going to gain 89. Okay. The variance X here denotes, I have used some formula to compute. You are going to see why that formula is going to come, but it is a deviation from the mean. It's average deviation from the mean. So 89 is the mean, 100 is one possibility. So 100 minus 89 is the deviation. With 0.9 probability, we are computing. We'll understand why there is a square later. Okay, so the same thing you do it for 10 as well, and you got some variances 733. And there is another term which is square root of variance, which is 27. So these are some numbers I computed. Expectation of some X and variance of X. Now we compare the two choices.
I just want to tell about variance, since we haven't actually covered that as part of my live lectures, but they had seen some of these things in the MIT lecture, which I give them for watching in the week. But nevertheless, I just want to say, like expectation, it is like a single number that represents the entire distribution. What is the best representative? What is the single approximation that you could have done? And variance is another quantity which tells how much spread is there in the distribution itself. So higher variance means it spreads more. Lower variance means it doesn't spread more. The previous choice, the variance was 0 because there is no spread, because choice 1 was you was getting 1 rupee for sure. So there was no variance. Whereas for this one, when you compute this, so we will see the exact formula in the class.
Yeah. Don't worry about it.
Yeah. But here you see that the number is higher, which means there is some spread.
That is understandable as well.
Yeah, that's all.
Yeah, correct. Thank you. So I will tell some more detail about mean and variance in another context, but I hope you guys understand how it is computed. It's some way of computing. We'll try to understand it a little later. So the point is this: we need to make a choice for which the mean is high. So there are two choices. One, on an average, I will get this better. And then we need to also choose a choice for which variance is low. If you choose a choice where the spread is more, you may get any of one of the result. Okay. So that you have to be careful. In this case, it was very clear. So there was a mean and variance. Even if you add plus or minus the standard deviation, you are going to be far from the choice 1. But that may not be true in all the choices you are going to make. So you have to make a decision based on both mean and variance. It's just your own way of doing it, playing it. We'll try to understand that. So
one statement I want to say. So, so everybody saw that there were 3 types of policies we saw. So a policy is in a decision making, you have to decide what to do. That is a policy. Okay. So first policy was Siddhant's, which is like he was using very, very casually. I mean, we're not thinking, I mean, not trying to mathematically say anything. He was just coming up with a solution. That is fine. I mean, this is a small stake decision. He can do like that. Gut feeling works well. Intuition works well. That was Siddhant's policy. The second policy, what Advait said, was to look at just expectation and just see if the expectation is positive. Yeah, you go ahead and play. Now, what the third policy, what we are seeing here is expectation alone may not be enough. You need to see what is the spread. Okay, because if the spread is large, even though expectation is positive, you have a good chance of getting a loss. Okay, so that's why variance also comes into picture. So a best policy is to basically not just look at expectation, but also see the variance. Why does that become important? Because if the decision is high stake, if you are running a huge company and you are having this kind of a dichotomy, and if you play with the risk, you may actually cause a lot more damage. Okay, so you have to be risk sensitive.
Yes.
That's all.
Okay, so now let me just because what is the relation to physics? Anybody can tell what is the expectation correspond to in physics? Anybody who has done? Everybody has done IIT JEE, right? So they should be able to tell what can expectation be. Anything you can think of?
So it like mathematically it looks similar to weighted means.
Okay, weighted mean. Have you seen anything in physics like that? Weighted mean?
No, sir, but in
Center of mass is like a center of gravity.
Yeah, center of mass or center of gravity. We can take center of mass, right? Yes. So center of mass is one analogy. It is exactly the same thing. It is where you will concentrate one mass. If suppose you have a rod which is of length 1, the center of mass you will say is located at half, right? So you will place the mass with that portion. So that is what expectation is going to give you. So what do you think variance will be? Can someone tell?
sir, surety can be like.
But in terms of physics, you guys have seen. See, now someone said center of mass. That person can tell, or anyone else can also tell, where else the variance comes in the physics. What does variance correspond to in any quantity? Anybody? Where does the spread play a role in physics? How does it spread?
So maybe the region surrounding the center of mass on either sides.
Correct. So that is used. That is moment of inertia, right?
Yeah.
See, the moment of inertia denotes the ability of the body to rotate. If the mass is spread too much or too thin, that gives the ability of the body to change its rotation power, right? So that variance is corresponding to moments. Actually, it corresponds to a quantity known as moments. Based on where you are going to put the center, you may get different moments. So if you put it at the center of mass, that is exactly what a variance is. Okay, so you can relate to this, you can think over, and they are the same quantities essentially. It is not something new. So distribution is the mass density, where you are going to read about distribution function, and expectation of x is the mean, which is the center of mass, and the variance will correspond to the moment of inertia of an object. Okay, so having said that, let's move on to the conclusion of this. See, we have seen an example. This is a toy version where you need to take a decision making, but in real time, you have to invest, as Satya was saying, between two or more choices, where you may get a steady state interest, 10%. I don't know, nowadays it has become extremely low, but then the other choices like stocks you can invest. But how do you analyze these decisions? So you need to make some calculations, but you won't be able to do it intuitively. You have to do it systematically, right? So that is what is being, it's a toy version of that is what is discussed today. So before we move on to this, a quick summary of what we have seen in the two examples, Monty Hall problem and this toy problem, is definitely probability is going to help you in making your decisions well. Okay, so that is what I would say. Okay, if anybody has any other opinions, we can discuss on that as well. Okay, all right. Now let's move to the next topic, which is Monte Carlo integration. Can someone tell what is the integral of this function?
Sir, it's 1/3.
1/3. So you, okay, how do you do it? I just want the steps also.
Sir, integration of x square is x cubed by 3, and
Okay.
then putting the limits.
Okay, thank you. Your name?
Sanjay, sir.
Sanjay, thank you, Sanjay. Now, what about this, Sanjay? Can you tell what is the answer?
It takes time.
Okay, no issue. Anyone can say. Sanjay may not only try, everybody can try, and if anybody has an answer, they can also answer. Anyone? At least an approach would be helpful, so that I don't know what you guys are thinking. Okay, Sanjay, you have any suggestion?
I think it would be better if we go for approximations. Instead of finding the integral of square root of sin x, let us bound the integral on upper limit and lower limit and try to compute the values, and taking the limit and convergence of the left and right hand limit, we can estimate the middle one.
Yeah, but it looks like a very complicated process. Yes, definitely what your answer is correct.
We can take sin x equal to t square.
Yeah, someone? What is that?
So we can take sin x equal to t square.
Okay.
And then we can change the limit into t, dt. Then we can solve it.
Not so easy. By the way, your name?
Yes, sir. My name is Nikhil.
Nikhil. Okay, try it, Nikhil. If it works out, we can share some price. Okay, because I showed you the problem. You told the solution. You can give me some share. See, this integral is not having any closed form expression as such, Sanjay or Nikhil. Okay, so it's very difficult. So have to resort to what Sanjay is suggesting. You make some numerical approximation. So let's see what it means. It's very difficult to compute analytically. So the plot of root sin x is very easy to obtain. That you can just take any plot function and you can do it. Okay. Now, then you can do approximation what Sanjay has told. That is given in the green area, right? You can take some rectangles and approximate it, and it will be a tedious process. But there are some techniques in numerical integration, which is exactly what Sanjay was suggesting. Using that, one can compute. But you can also use probability here to get you the integral of this function. I'm not going to go into the details. I'll just tell you the algorithm. Maybe at the end of the course, you should be able to understand how it works. Okay. So the idea is very simple. You generate samples from 0, 1. What I'm essentially saying is you have 0, 1 interval. You randomly pick samples uniformly. Okay. I think everybody understands what is uniform. You can pick every sample equally likely. Every sample is equally likely, but it is an interval. That is a generalization of some discrete to continuous. Then what you need to do is for each of the sample, apply root sin ui and divide and take the sum of them and take their average. Okay. So that's all. This is known as Monte Carlo integration. This is just a one-dimensional integral, but there are multi-dimensional integrals which can come. Even that can be done in a similar fashion. Okay. So you guys are not knowing about law of large numbers. So if you use law of large numbers, there's an idea that this roots sin ui, the average, will converge to the true integral. Okay. So I'm not going into the details of these things. Okay. Now the MATLAB code for doing this is simple. You take rand, which will give you uniform numbers in 0 to 1. 1,000 of them you have taken, and then compute the square root of each of the entries. That is y for you. Then take the average of the mean. So just a 4-line code which computes this. It's just much better than this numerical integration at some occasions. So what I am trying to say is this is one more example of probability getting used to perform some kind of integration or doing some calculus by doing some kind of sampling appropriately and then averaging whatever result you have got. So in order to understand what has exactly happened, you need to understand what is law of large numbers that you are going to learn in the course. And then you can go back and see this example, then you will be able to understand this example much better. But essence of this is, it is used to perform some integration. The idea is also quite simple. If anybody has any question, I can take it. Otherwise, we'll go on to the last
Sir,
topic.
on the previous slide, you wrote
Yes.
like as n tends to infinity, does this E means expectation?
Yes, expectation, which we have seen earlier. So these things you are going to learn in your course. See, I'm not telling whatever has been based on already what is taught. It is just a tour for you to see why you should read this course, what is the importance of this course. Okay. Yeah, this is the same expectation which we have used. It's expectation of a random variable, function of a random variable. You use a uniform random variable. You take sign of that random variable and then you compute the expectation. Okay. So that's all. Any other question? So expectation of that root sin u will turn out to be your integral. So that is why if you take samples and then average, it is going to converge to your answer whatever you wanted. Any other question here? Or I can move to the last topic. We have another 10 minutes. Yeah, and then at the end, I can also take questions if we finish it early. Okay, I think we will move to the last topic. So I want you guys to understand the algorithm. Okay. If anything is not clear in the algorithm, please let me know. So what I'm going to do is take a point randomly in a plane anywhere and then apply some function f, which I have with me. I'm going to explain what that function is. Okay. Then you are going to get a new point. Okay. Now take the new point and apply the same function again, and you will get another point. So you are going to just take this and take a new point and take a new point and so on and so forth. We are going to see what kind of pattern can come out if you choose a function in a particular way. Okay, so the choice of the function is as follows. There are 4 functions from which I can choose. I'm not going to use all the time the same function. So what I'm going to do is every time you have a point now I have to choose one of the 4 of these functions. The first function I'm going to choose with a very low probability, 0.01. The second function I'm going to choose with a high probability, 0.85. And the other 2 functions with equal probability, 0.07, which is slightly higher than the first function's probability. So these are the probability with which I'm going to choose one of these functions, and I will take the point which I had earlier and then apply this function. Okay, now I get a new point. Now using this new point, I'm going to again do the same thing. I'm going to take one of the 4 functions according to these probabilities. This is known as sampling, according to certain probability prescribed. And then once the function is chosen, then apply this. This is just linear algebra. You multiply by a matrix and add some vector, so you get another point. Okay, is this clear, the step of the algorithm? Anybody has any question in the steps? If not, I can tell you what kind of pattern may emerge from such kind of things. Any question in understanding the algorithm? Okay, anyway, so let's, if anyone can guess what may come out of it from these things. I don't think anybody can guess, definitely, unless people have seen it already. But what do you think is going to come? Is it going to be a circle? Is it going to be something? What is that you guys think may come out? Any guesses?
See, Prabhu, even though I have seen it, but if I had not seen it and if I try to put myself back, and I would imagine that it will just generate some kind of a noise. And since there is a high probability for this particular function, I would assume that that function will be more prominent than the other. So if this function is a line, basically, this is a line. So I will think like going to be a line somewhere, but since the points keeps alternating, the lines will also keep changing. So I would guess it's like a quite a messy figure is what I would guess. That's, I mean, even if I know it, I'm just saying, because if I didn't know what I would say. Yeah.
No, definitely. That's very good, actually. Good, Satya. Yeah. That's fine. This is a linear function. So if you take the function f2 and keep plotting that, it is going to give you a line. So that is going to be chosen very often. So you may expect a line, but something like that, right? So let's see what is going to come out of it. Okay. So this is what comes out of it from just that 4 lines of, I'll show you some code also on that. Okay. So you have a leaf like structure, which is emerging out of this simple algorithm. Okay. This is known as a Barnsley fern. It is not a real fern. If you guys know what a fern is, then you will be able to relate to it. It's just a leaf. Okay. It has some self-similar structure. Okay. So what that means, you will understand. I'll show you in the video. It also is similar to the real ferns, which you can see in nature. This is like leaves, right? So now let me just show you the code, what you can see. Okay. Let me see Python. Yeah. So no such directory, it says. Okay.
It's called Pern. What is that called?
Pern wiki. Okay.
Yeah.
Okay. All right. Yeah. I changed the name. See, it's a wiki code, so I have not done anything great. So I'm just trying to show you so that you will believe me. So you see how it is emerging, the pattern. So I'm not cheating you or anything. So that's why I have just shown you this. All right. So you can keep seeing this. You can play with the code later. Okay. I'll just stop it and then quickly maybe show you what is the self-similar structure or something which I was telling you. Okay. So this is the fern example which we have seen, which is generated using MATLAB code. And the self-similar structure, I'm going to just go to that because we don't have a lot of time. See, if you take any frond or any line, it will be the same pattern is going to emerge. And if you that is what is the self-similar structure. These are known as fractals. Okay, you can go and read more about it, and it has other applications in chaos theory and all that. So what you have seen is this example from a simple algorithm where you take a point, you apply some function, but the function which you are choosing is in a random fashion. Then you are going to get something like this, right? I think this is definitely very beautiful structure, but also very complex, right? So these are the 3 important features: complex, self-similar, obviously beautiful. That is just an aesthetic thing. But there are a lot of applications using these fractal ideas. So I'm just trying to summarize what we have seen today. Okay. So today we saw how probability helps you in making decision making when there is uncertainty around you, right? And you're going to read more applications of probability. Someone said machine learning, and it's also used to analyze algorithms in randomized algorithms. It is also used in game theory. It's used in stochastic optimization. These are all the branches where it is going to be heavily used. But what I want to do today is, you people see its application in very close quarters. You can make sure, you can convince yourself that it is useful, really. So when I started, I thought maybe probability has, what is the point of computing the chance of this, etc. But later I realized even that may be used to make decisions. If you don't account for such things, the decisions may be poor. That's what the Monty Hall problem suggests you. And you need to make some computations. So like expectation variance, that which we will learn in the course. Also, it has other application in performing integration, in doing calculus, and these things are going to get used in, even in machine learning. So probability is going to have a lot of uses. Okay. So with this motivation, I would, if you guys have any question, I can take it. Otherwise, you should study your course very well so that you can utilize probability in various applications when you go for a job or even in higher studies, etc. Yeah. So then now I will end here. Any questions, guys?
Sir, Satyanath sir told that there will be since the probability of F2 was a lot, so there will be there will be a line, and then then there will be other noises. So sir, is the main stem the line? Because if the main
that
stem
is not the only line. That is not the only line. See, there will be multiple lines. Once you change the direction and you switch to something else, the line will continue in that direction. That is what you will see if you look at the code. I close the code. Okay, you see here line is coming in one direction. Once it switches to something else, there also you are going to create some lines. Okay, so it is not so easy to understand it. Yes, it's a good intuition that it is going to be a line, but once you change from that point to some other point, what is going to happen now? Okay, so it will not be a strict line because you are not going in the same direction. Your points are also changing. Okay, you go back and forth, right? So what is your question? Did I answer your question or something? I don't know. I don't know who asked, so I don't know your name. So can you, if you have understood, it's fine. Otherwise, you can still ask. Not related to the fund alone, you can ask any question based on whatever we discussed today. Or if you have any general question also, it is fine. We can discuss for a couple of minutes. Anyone? Okay, so my suggestion would be for you guys to learn this course, understand law of large numbers, then you will understand Monte Carlo integration, understand expectation variance, then it will be used further heavily in machine learning. These terms will keep coming. Okay. Yeah, and decision making is what reinforcement learning is about. When you have uncertainty, how do you handle uncertainty and take optimal decisions? So if someone is interested, they can also pursue such disciplines. So because I am from machine learning background, definitely even in algorithms, you can utilize it for analyzing quick sort and algorithms. You need to randomize so that the algorithm can even perform well. So these are some things which we have seen. Yeah. Satya, I would say I've completed the presentation. If you have any points you can add, or
no, I think this was quite comprehensive. I mean, the idea was I just wanted everybody to see a different view as well, because I have been speaking several times. So yeah, that's the whole idea. And I think all these examples are useful to see for anybody. So that's why, yeah. So then thank you very much, Prabhu, for taking the time to come here. And yeah, so we can end here. So thank you, everybody. Have a good lunch. So we will meet next week. Thank you.
Thanks, Satya. Thank you, guys.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.